Hi guys, and welcome to my video on using recurrent relations to analyse and model reducing balance loans and annuities. I need to lie down, these titles are nuts. Alright, my name's Darren from Maffs Guru. Hopefully you've watched some of my stuff before and I'm welcoming you back. But if you are new, do me a favour, head to maffsguru.com and sign up absolutely free, where you can download these lesson notes behind me and write all over them. You can watch the videos in order mapped against Cambridge, and what else you can do? Oh, exam questions, time codes, and a lot more coming, I am sure. Now, obviously, if you're going to subscribe to my YouTube channel, and great, that would be awesome. As I say, just let me know that people are watching. If you want to, turn off notifications if you don't want to be spammed. I don't spam, I produce videos every day pretty much if I can, but you know, your help would be greatly appreciated. Now, as you can see, what I normally do is I normally go through that there. They basically is just what's going to happen in the lesson. Pause it if you want to see what I'm going to go over and if it's going to be useful. Hold on a minute. Of course it's going to be useful. I wouldn't be doing it otherwise. And then we'll actually move on to the important stuff. Now, I don't know about you, but if you've watched all the videos on my series, you are probably bored to death of this particular formula here. This recurrence relationship is like, I don't know, the Lord of the Rings. It's like Gollum. Do I look? No. Please, God, don't tell me I look like Gollum. Right? He's not looking rough. He's looking rough. But basically, it's like that is the one rule to rule them all. See what I did there? Pretty bad? I thought so too. Understanding this formula is going to be the trick to pretty much everything in final maths and the context of the questions, because we're going to do the financial solver stuff coming up pretty soon. Now, we're going to start using mathematical language. So rather than the start amount, I'm changing it to principal, because when you go and take out a loan, it's called the principal. When you put money into a bank account, it's called the principal. We know here now that that is my rate of interest written as a multiplier. It's a 1.0 number if we are adding money on. This plus or minus D could be some sort of payment we're paying in or some sort of payment we're taking out. And we know that our R value can be worked out by using 1 plus R on 100 or 1 minus R on 100. And again, if none of that made sense, go back to my previous videos. They're all there for you. We're going to start talking about reducing balance loans. But before I go any further, the rest of this course has 3 main concepts that you've got to get into your heads. And I don't mean that to be disrespectful. I'm just saying these are the way we trick you guys. One is called an annuity. He says trying to spell it properly. One is called a perpetuity. And then we are going to be looking at something called interest-only loans. All right, now these each have their own peculiarities, but an annuity is basically just a massive piggy bank. All right, it is literally a massive piggy bank. You may have heard of it slightly differently as a super, but I don't want to rush ahead because that's coming up later. What I need you guys to realize is that actually the language is going to slightly change in the questions. Financial maths has its own language. Principal, as I just said there, is basically the amount we're going to open an account with or the balance of a loan we're going to take. Every single account was going to charge you interest. A loan is going to charge you interest. You put money into an investment, it's going to charge you interest. Interest is always, 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 always added on, which means that your R value is always going to be greater than 1. All right? Always, always, always. You're going to have to pay back the money over a period of time, right? So you're going to have to pay it back. And I'm going to be making payments, right? So payments are going to be important to me. I'm going to make a number of payments because like my mortgage for the moment is over 30 years. Well, they're not just going to allow me to make 30 payments because I'm going to pay it every single month. So in which case I'm going to do 30 times 12, lots of payments, aren't I? Yeah. So that's a lot of payments. So what is that? 360 payments. But will I always make 360 payments? What if, I don't know, I come into some money? What if maffsguru.com, every one of you rushes over there and sort of subscribes for, you know, a little bit, 20 bucks to get bits and pieces, I'll be rich. So I'll be able to pay off a bit of my mortgage. So in which case I won't be paying for 30 years, I might only be paying for 20 years. So the number of payments will change, yes? My interest rate could change. Why? Well, the RBA at the moment seemingly are trying to drive me homeless. And so, you know, the point of it is interest rates are going up. Well, that makes huge changes because my payment will change if the interest goes up. All right, so getting the context of the question and the language we're going to use is really, really important. But what we're trying to do here is we're trying to look at loans that reduce. So what I want you to think about is this. If I took out 300,000 as a loan, the bank are going to charge me some interest. I'm going to make a payment to try and reduce my loan. Is my payment Or does my payment have to be bigger than the interest, the same as the interest, or smaller than the interest charged? Now obviously pause and think if you want to, but I would hope that the payment I'm making will be bigger than the interest, because otherwise I'm never going to catch up. If I don't ever pay off the interest, then my loan is going to go up and up and up and up in value, and I literally will be in all sorts of trouble, which people sadly get into with the idea of credit cards, but we'll leave credit cards for another day. So let's just go back and look at this again. Our reducing balance loan will have this formula here. V0 equals principal, V of n equals R times V of n. So that R value is always going to be bigger than 1. And we know that here because it's 1 plus R on 100. That will always give a value bigger than 1. And minus D here now. Now, a lot of people get confused there because they're like, well, hold on. When I give money to the bank, I'm paying them. You may well be paying money into the bank, but you're trying to reduce your loan. So that's why it's negative. And getting those sort of things right is really important. Flora borrows, I love an example. Thank you, Cambridge, for allowing me to use your example. You guys absolutely rock. Flora borrows $8,000 at an interest rate of 13% per annum. Now, if you've watched my previous videos, you will be looking at this going, oh, hold on a minute. We've got to make sure we look at not just the per annum, but what it's compounding as. And because in this situation, it is compounding annually, I don't have to do any funky calculations. I can use my little r, in this situation, is going to be 13%. She makes yearly payments of $2,100. Construct a recurrence relationship. Oh my God, haven't we done like a 9,000 of these? Yes, but what do they say? Practice makes perfect. A V0 is equal to 8,000, comma, a V of n plus 1 is equal to R. I want capital R. I don't have capital R. I have little r. Oh, but I can work out capital R as 1 plus 13 on 100. And again, I can do that one in my head as 1.13. Sorry, not percent, because it's a multiplier. So that becomes 1.13 times by V of n minus D. What is that? Oh, that's a payment. Oh, well, hold on. She's making yearly payments. So minus 2,100. Oh, loving these questions. Read the question. Alyssa borrows 1,000 at interest rate of 15%. Here we go. So I know I've got V0 there. I've got my little r already. They're changing it. They're compounding monthly. So before I go any further, I'm going to write that my little r is actually 15 divided by 12. All right, we'll leave that there for the moment because I can do that on my calculator. She is making monthly payments. Now again, notice compounding monthly. She has to be making payments monthly. It's so important that they are the same, otherwise it's not going to work. You'll make horrible, horrible mistakes. Construct a recurrence relation. I'm getting a bit bored of that one actually. So 1,000, thank you, comma, V of n plus 1 equals R. I need my capital R. So it's going to be 1 plus, what is 15 divided by 100? Again, 15 divided by 100. 15 divided by 12 is 1.25. Divided by 100, and so my capital R is equal to, again, I'm doing all this off screen, guys. If you want to basically, play along, but I'm fairly sure you can do this on your calculator. 1.0125, 1.0125, and again, why do I always run out of room? So let's circle these and move them over. And what have we got? That's going to be times V of n minus, she makes monthly payments of $250. So I'm going to minus the 250 because she wants to make the loan less. That's why we're taking it off. That would be 2 marks in a VCAA exam. All right. For some reason, recurrence relationships, generally speaking, they give you 1 mark for that with the comma. 1 mark for that. All right. So fingers crossed you can at least get 1 mark out of these in a VCAA exam. Alyssa's loan can be modelled by the recurrence relation. And when I taught this earlier today, I was like, hold on a moment, that was the value they gave, but they obviously changed the context. So Alyssa's loan can be modelled by the recurrence relation. Use your calculator to find the balance of the loan after 4 payments. Now, obviously, rather than use my calculator here, what I just did was the screenshots. So again, I put in my 1,000. There was my V0. Then I typed in my formula. Everywhere I saw the V of n, I made it the ANS button. All right, then what did I do? Well, I hit enter how many times? Well, it wanted 4 payments. So I hit my enter key once, twice, second, and third, once, twice, second. No, 1, 2, 3, 4 times. There we go. What do we get? Now, reading that is critically important. Why? Because it tells you what Well, each of the figures we've been given here have been in dollars. So this is a dollar amount. She's got $0.04492. So basically, use your calculator to find the balance. She actually owes 4 cents, 0.04, not $4, 4 cents. So here's my next question to you. What would she do with those 4 cents? Well, hopefully it would make sense that the bank would turn around and say, well, hold on a moment, you're only going to owe 4 cents at your next payment, or your last payment, or your fourth payment. So actually, why don't you pay us $257.89? Then you're going to clear the loan. You're not going to owe us anything, because otherwise she's effectively going to end up having to pay the bank interest on 4 cents. And you're going to say, well, that ain't going to be much. Well, do you really want to pay the bank even a cent more than you need to? Hopefully not. Find the balance of the loan after 2 payments have been made. Round your answer. Well, that was 1 payment, so that was my second payment. Find the balance of the loan in that situation would be $506.23. Notice again, the ability to round to 2 decimal places, really, really important. Now, as I said earlier in the beginning of this video, an annuity is really, really important, all right? Annuity is basically just a big piggy bank, but when you put money into your account, if I put, say, 100,000 into a bank account, 100,000, I don't even think I've got $100. If you put $100,000 into an account, I am going to get interest on that every single month. That's what the bank do. They reward me by paying interest. But I probably want to pay some money in as well. So out of my salary, I probably want to pay a bit extra so that I can make my money grow faster. The more I put in, the more interest I get. The more money I put in, the more interest I get. And basically that's the idea of an annuity, which, as I say here, is basically, that's me in old age. Yeah, I'm not too sure why I've got so much facial hair, but I'm losing my hair. Anyway, whole new discussion. So basically the super, I lost my point there. I was like, what was I talking about? My superannuation. All right, I started with actually nothing. When you open a superannuation, you've got no money in there whatsoever. But every month, my employer pays money in, and I pay some money as well, right? So there's a contribution that we make. And every month, my super grows and grows and grows. The more I put in, the more I'm going to get, which is why it's really, really good. It's going to pay for my retirement. But one day, I'm going to stop working. One day, I'm not going to be paying any more money in. I'm going to have finished. I'm going to be done. Hopefully, by the time I retire, let's say I have $1 million in there. All right, this now has to pay for my retirement. I have no more income. So every single month, I am going to have to take out an amount of money. And that's up to me to decide how long I want my annuity to last. I may decide to take out $2,000 a month, and then I can work out how long my annuity is going to last using a financial solver. It gets more complicated. It's not as simple as saying 1 million divided by 2,000, because you get interest. All right? I can take out 10,000 a month. I can take out 100,000 a month. But the more I take out, the quicker that money is going to disappear. So understanding what an annuity is really important. But weirdly, what do you notice? It seems to be exactly the same equation as we just had there, didn't it? I mean, there's my R, there's my interest rate, there's my VN. My minus D in this situation, I'm taking money out of my annuity, all right? So I've got this $1 million. I'm taking out $2,000 a month because it's going to reduce. And why is R positive? Because the bank are paying me interest. They're going to reward me for having money in there in this annuity. So here again as examples, what you're going to find is the theory is going to become less, the examples are going to become more, because understanding how to decode questions is probably more important than me wetting on about what an annuity is. Reza invests $12,000 in an annuity. Now luckily the question here tells you it's an annuity. Fingers crossed it'll tell you in every question. It earns a rate of 6% per annum, so my little r is 6, isn't it? No, because I've got to continue moving on the question up. It's compounding monthly. So the next thing I'm going to do is divide that by 12, which gives me 0.5. So that's my little value of r. Providing me with a monthly income of $2,035. Be careful here. Model this annuity using a recurrent relationship of that form. Well, it's the same form, all right? We know that, but why is it minus? All right, it says here it's providing, and that sounds like it's being very positive. Thank you, give me money. Because, sorry, what we've got to realize is that for an annuity, my value of my annuity is going to reduce now by $2,035 every single month. That piggy bank is eventually going to run out, and I'm going to have no money left in there. So, going back to exactly the same type of question that we've done about 47,000 of these before. V0 is 12,000, V of n plus 1 equals my big value of r. R is equal to 1 plus 0.5 divided by 100. Let's do it on my calculator. 1 plus 0.5 divided by 100 gives me 1.005. So 1.005 times V of n. Let's actually mix it up this time and move this over. What have we got then? Minus D. What's my D? Well, that's how much my annuity is going to pay out, and it was $2,035. Ka-ching. Again, in a VCAA question, that's generally going to be worth 2 marks. 1 mark for this, 1 mark for that. But don't hold it to me, because knowing my luck this year, VCAA will change it and only make it 1 mark. And then I look very silly. This was basically the working out for the question I was just working on. We'll look at part B now. Rather than bring up my calculator, I've done screenshots, obviously, for the students I'm currently teaching. Makes my lessons a bit quicker. So what have we got here? What is 6 divided by 12? What was this, 0.25? Well, that was my little value of R, if you remember. There was my capital R, so that's my calculation for my capital R. Obviously, here now, use your calculator to find the value of the annuity after the first 4 months. So what have I done? Well, I put in the 12,000. Remember, there's my 12,000. I've obviously put in here 1.005 times ANS. The calculator's changed it to my previous value, minus 2,035, and then I've just done it oops, what happened there? I just did it 1, 2, 3, and 4 times. So after those 4 months, the value of my annuity would be $4,040.55. Ka-ching! I'm rich, or not really, because what you've noticed there is with such a large amount of money coming out, with $2,035 coming out, that $12,000 is pretty much gone after 5 payments. There'll be a little bit left after it, but not much. Now here are some VCAA questions. Love VCAA questions. The balance of a loan, VN in dollars after N months, and again they give me N months, so I always tend to highlight that because it's important, is modeled by the following recurrence relationship. All right, so this must be my monthly interest rate. I've obviously opened up with 400,000 and I'm taking out 2024. The balance of the loan first falls below 398,000 after how many months? Well, in which case, let's bring up my calculator. I don't have screenshots for this, so let's say we're going to do 400. I've done it again, I hit the picture. 400, 1, 2, 3, hit enter. All right, so 1.003 times, answer please, minus 2024. Now, once after how, we've got to work out. So we're now going to look for when the figure on my calculator gets less than 398,000. So 1, 2, there we go, 3. So after 3 months, the value of my loan will fall below 398,000. So in that situation, I think we put C as my correct answer. The world goes crazy. You are a genius. To purchase additional workplace equipment. Now, obviously, this seems like it's continuing on from a question. So, yeah, because this is from exam 2, they're generally context-based or what are they, sort of scenario-based. They've obviously got a situation here where Pina is running some sort of manufacturing workplace. But anyway, to purchase additional workplace equipment, Pina takes out a reducing balance loan. And again, you've got to understand what that means. With interest calculated monthly. All right, so interest is calculated monthly. That might be important. And that 580,000 might be important. The balance of the loan in dollars after N months can be modeled by the recurrence relation. If you notice what they've done here in the exam as well, they haven't used V. All right, and again, that is a deliberate tactic for exams, because if they tell you in the question to use L and you use V, you get no marks. All right, and I'm going to say that again. Any of my students who are watching this, in your SAC, you don't use the letters that you asked to do, you're going to score 0 marks. I'm sorry about that, but it's the way it goes. Right. Show recursive calculations determining the balance of the loan after 2 months. Right. Now, when it says show recursive calculations, you have to show all the calculations. And again, if you're out there watching whinging that this is a lot of work for 1 mark, that's the way it is. VCAA questions are 1 mark, very occasionally 2 marks, and some of them will require working out. And for the data section, they require a lot of words as well. So, recursive calculations. That means they want you to write L0 is 580,000. L1, they don't want you to just write the answer, they want you to write the calculation that will get the answer. So that would be 1.002 times 580,123 minus 3045.26. Yes, you would have to write this down. Yes, I've now got to work it out. So let's do 580,123. Now, again, I can make my calculator make my life a bit easier by actually doing the recurrence relation, minus 3045.26. Is that right? 3045.26. And hit enter. So that's going to give me 578,114.74. Right, so I'm going to turn that off there. And then what does it want? The first 2 months. So I've got to do another one. So I do 1.002 times my previous answer, 578,114.74 minus 3045.26 equals, I'm just going to hit enter on my calculator, guys, so I don't need to bring that up, would give me 576,225.71. And there we go, put the dollar signs in probably, but that's what they want. And realistically speaking, the students who don't want to do that throw away marks, which actually give marks or better chances to other people. So don't be one of those people who goes, it just seems too hard and too long. 1 mark for literally just copying that formula and putting some values in. The additional, so basic, now moving on to part B, exactly the same context of a question. Determine the annual compound interest rate. They want annual rate. But this isn't an annual rate. That 1.002, again, is not an annual rate. That is my capital R. So determine, so capital R in this situation is 1.002. We know that capital R is given by 1 plus little r on 100. So I've got 1.002 equals 1 plus little r on 100. What do? Well, I can solve that. Now, don't write ever in an exam the calculator notation. Just do it, all right? So, oh my God, I've hit the group. Solve, what I've got, 1.002 equals 1 plus r on 100, comma r, hit enter, and that gives me 0.2. That little r equals 0.2. But again, ask yourself the question, is that actually my annual interest rate? No, because this value here basically is my monthly interest rate. How do we know that? Because it said it was calculated monthly. So what I would need to do then is times that by 12. So therefore, my annual rate is equal to 0.2 times 12. I'm embarrassingly going to do that because I don't want to make it wrong. 2.4%. Ka-ching. All right, 1 mark. Do you have to show all of this working out for that 1 mark? No, not in a 1 mark question in this situation, because it didn't say show that. You could go straight to the 2.4. I don't think it hurts to actually show you're working out. For renovations to a coffee shop, Sienna took out a reducing balance loan of $570,000 with interest calculated fortnightly. That might come in useful. The balance of the loan in dollars after n fortnights can be modelled by this recurrence relationship. Calculate the balance of the loan after the first fortnightly payment is made. Again, we'd fire up our calculator. It's actually quite nice and easy, this one, because I don't even have to do a recurrence relationship. They only want 1 payment. So 1.001, 1.001, I'm going to times that by 570,123 minus 1193, hit enter, and what do we get? Not in highlighter as well. It's all going wrong. $569,377. Ka-ching for 1 mark. Now again, a lot of the questions for these exams start nice and easy. They get a little bit more complicated to test whether you fully understand. Show that the compound interest rate for this loan is 2.6%. Again, show that. In this situation, you have to show you're working out. All right? Now, how would I do that? Well, I've said a moment ago that we know that there is my, fortnightly interest rate. So we know that capital R is 1.001. So I'm now going to do 1.001 equals 1 plus little r on 100. Put that into my calculator. It says typing on the right one this time, so I'm going to solve. 1.001 equals 1 plus little r divided by 100, comma r. Hit enter, gives me a little r of 0.1%. Now my brain automatically says to me that seems very, very small. And that automatically tells me that actually, nah, it's got to have a multiplier. So in that situation, my per annum, my nominal interest rate is going to be 0.1 times 26. Why is it times 26? Because it is fortnightly and there's 26 fortnightly, which gives me 0.1 times 26 should give me 2.6. And there we go, 2.6%. That is a show that question. I have shown my working out. And the examiners will only give you an answer, or only give you the mark if there is an indication that you have worked out your value of R. I'm guaranteeing they're looking for 0.1 and then 0.1 times 26 for you to be able to get the mark. You can't just write 2.6%. even if you've worked it out on your calculator, because you haven't shown that. And there we are, done. Thank you very much. Maths Guru, I am there, mathsguru.com, free to sign up, downloadable notes, etc, etc, etc. If you can, subscribe to my YouTube channel, greatly appreciated. Turn off notifications if you don't actually want to hear from me. Please don't. I'm on Instagram and all those type of social media places, Facebook, etc, etc. And hopefully I'll see you over there or in another video. If not, please take care and stay safe.